The topic simple harmonic motion, how we define the term simple harmonic motion. Basically, in a simple harmonic motion, the acceleration and displacement or acceleration directly proportional to displacement from the mean position. So any motion, if we are able to prove this relation that acceleration and displacement are directly proportional to each other, we call that as simple harmonic motion. So what is the definition of a simple harmonic motion? How we define the term simple harmonic motion? Basically, in this motion, the force or acceleration is proportional to displacement from the mean position. And the force or acceleration is always toward the center. So, when an object is moving or undergo a simple harmonic motion or oscillation to and fro, either side from the equilibrium position, the maximum displacement is known as the amplitude and time to complete one vibration is known as the time period. So, example, say there is a mass which is attached to a spring, and this is oscillating to up and down. So according to Hooke's law, as we know the Hooke's law, that force is equals to F is equals to kx. Force is equals to spring constant multiplied by extension. So we can say F is equals to ke, or we can also say F is equals to kx. When we talk about the force by the spring, because the force by the spring will be in opposite direction of the force which we apply, so we can say F is equals to minus kx. Why minus? Because that is the force of the spring. So force exerted by the spring will be equal to minus kx. The reason, that's a restoring force, or the force will try to move the spring towards the equilibrium position. And we know here the force which is applied on the spring, that F is equals to, force is equals to weight, or we can say mg, or F is equals to ma, we can also say, where a will be equal to acceleration due to gravity when object is moving in a vertical plane. But if the object is moving horizontally, the spring is on the horizontal plane, in that case the F is equals to ma. So this is a spring which is attached, the mass is attached to a spring, and this is oscillating or vibrating to and fro. So in that case, F will be equal to ma. So in place of F, we can write ma. So we can say ma is equals to minus kx. And here, as you can see, according to the simple harmonic motion, what is a simple harmonic motion? A motion in which either force is directly proportional to displacement, or acceleration is directly proportional to displacement. So F is equals to kx. So k is the constant, and equal to, whenever we replace the constant to a constant and equal to, we'll replace by proportionality sign. So it means F is proportional to minus x. Or when we write F is equals to ma, or a is equals to minus k divided by m into x. So a is equals to minus k divided by m into x, and k is a constant, the spring constant, and m is a mass of an object that is also constant. So when we replace the constant and equal to, again we replace by proportionality sign. So x is proportional to minus x. So both cases, like, we are able to prove this, that force is directly proportional to displacement, or we say force is directly proportional, or acceleration is directly proportional to displacement. And negative sign, what it suggests, that it is always toward the maximum acceleration, or the direction of the force or acceleration is opposite to direction of the displacement, or it is always towards the mean position. So a mass which is attached to a spring is actually performing a simple harmonic motion. Why? Because we are able to explain this relation, or get this relation, that F is proportional to x, or F is proportional to, or A is proportional to x. So a mass attached to a spring will undergo a simple harmonic motion. Is it clear, the first part, that how a mass attached to a spring is performing a simple harmonic motion, as it follows the definition of a simple harmonic motion, that force and displacement are directly proportional to each other. Then how to find the time period, how to work out the time period of a oscillation for a mass which is attached to a spring and it undergoes simple harmonic motion. So we have the formula that F is equals to kx, and same thing when object is oscillating, vibrating, like moving in a circular path, the force, the centripetal force, we have F is equals to m v square over r, where v is equals to r omega. So in place of v, we can write r omega. So we can say F is equals to m r square omega square divided by r. So when we simplify, we can say F is equals to mr omega square. So it's like relating the circular, like vibratory motion with a circular motion. So if we relate the vibratory motion with the circular motion, so according to circular motion, the force is given by mr omega square. So we have the formula F is equals to kx, that is when a mass which is attached to a spring is performing a simple harmonic motion, and if identical object is there which is moving with the same time period, but instead of vibrating, it is moving in a circular path. So if there is an object which is moving in a circular path, so the force when object, this is a radius, m is a mass, and omega is the angular speed, so that is given by mr omega square. If we say that both have the same forces, so we can find a relation here between the circular and the motion and the simple harmonic motion. So if we say both forces are equal, so we can write that mr omega square is equals to kx, because this is kx and this is mr omega square. And what about x? X is basically the same as the radius. How x is a, this x is a displacement, which we also maximum displacement, it will become amplitude. So example, how I can relate a circular motion with a simple harmonic motion. Say there is an object, like there's a lamp, an object undergo a simple harmonic motion. So when we have a screen at the bottom, so if there is a screen, and on the screen, if we see the projection of this object, so how we will see the projection of this object, or the shadow, I can say. So when object is, say example, at position, when object is at position 1, its shadow will be here. When object is at position 2, so its shadow will be at this point. When object is at position 3, so the shadow will be here. When object is at position 4, So this will be the position. Then object at position 5. So this is 1. When we write the number 1, 2, 3, 4. So when it is at position 5, so the shadow will be at this point. When it is at position 6, the shadow will be at this point. So object is moving in a circular path, but you can clearly see its shadow is performing a simple like vibratory motion or oscillation, that the shadow is continuously vibrating to and fro. And the mean position, so this is a mean position, this will be the mean position or center position, and distance from center position to extreme position, that is known as the amplitude. Maximum displacement is called amplitude. So here this distance is the maximum displacement, or we can say x is equals to a. Here also amplitude x is the maximum displacement, and that time we'll call that as amplitude. So you can see when object is moving in a circular path, its projection is undergoing a vibratory motion or a simple harmonic motion, and we can say the radius will be equal to amplitude or x. Why? Because this distance, the distance from center to this position, so that is say r, and this r is equivalent to a. So we can say r is equals to a, or a is equals to r, both have the same meaning. So when object is performing a simple harmonic motion, object is in a circular, like moving in a circular path, and its projection is performing a simple harmonic motion. So we want to find a combined formula for this. So the force in a circular motion is mr omega square, and according to an object which is either attached with a string or a wire, that is F is equals to kx. So this is m, where r is the radius, and that is equals to amplitude. So we can say a and omega square, and here also this is k, and what is x? X is equals to amplitude, so we can say a. This a will cancel, the amplitude will cancel with amplitude. So m omega square is equals to k, or we can say omega square is equals to k divided by m, or we can say omega is equals to under root k divided by m. So when object is performing a simple harmonic motion, it is attached with a string, wire, or a spring, that time the angular speed is given by under root k divided by m. Now, how to get the time period? Look, the time period means time to complete one oscillation. So the angular velocity is equals to angular displacement divided by time. But for one oscillation or one vibration or the time period or a period, omega, what is omega? That is angular velocity. What about theta? When object move in a circular path, it completes its one rotation. So angular displacement is equals to 2 pi, and the time is t, capital T. Or we can say t is equals to 2 pi divided by omega. And what was the value of omega when object performing a simple harmonic motion attached with a string or a wire? So omega is under root k divided by m. So we can say t is equals to 2 pi under root k divided by m, or when we simplify, this will become t is equals to 2 pi under root m divided by k. So if you want to find the time period of an object which is attached with a string or attached with a spring and performing a simple harmonic motion, so we can use this formula to know, to find the time period of oscillation. Is it clear that how we relate a circular motion with a simple harmonic motion and derive the formula? for an object which is performing a simple harmonic motion. So T is equals to 2 pi under root m divided by k, where omega, remember that omega is equals to under root k divided by m. Then simple pendulum is also performing a simple like, why we call this as a simple pendulum? Because we assume that there is no air resistance and the gravity is constant. We simplify the motion, that's why we call simple pendulum. Even for a simple pendulum, how we can say it is a simple harmonic motion? We have to show either force is directly proportional to displacement, or acceleration is directly proportional to displacement and always directed towards the mean position. So how to do this one, like how to show this one? Say a mass is attached with a string or a wire, and we displace this to new position, and as a result, when we release from the extreme position, it will move and then it will return back. That's called one oscillation. The angle from the starting position, that is example theta. This is example the length L is there, and the maximum displacement from the mean position, the maximum displacement is which is there from the mean position, that is known as the amplitude. So here we can say amplitude is equals to maximum displacement. Now for this object, weight is acting downward, the gravitational pull is there. So this W is acting downward, and this W is making the same angle theta from the original position. So if you continue this line, this will be a straight line, so this angle will also be theta. So means W will have two components. The one which is with an angle, this will be W cosine theta, and against the angle will be W sine theta. So W sine theta is a component of the weight which is directed toward the center or responsible for the motion towards the mean position. So we have the formula F is equals to ma, force is equals to mass multiplied by acceleration, and force, what is the force here which is causing an acceleration? That is equals to W sine theta. So W sine theta is equals to ma. And what about the W, the weight of an object? W is equals to mg, so we can say mg sine theta is equals to ma. Then m will cancel with m, mass will cancel with mass. So whenever object attached with a string and performing a simple harmonic motion, its acceleration is given by a formula A is equals to g sine theta. That is acceleration. Then what about the sine theta? So if we consider a right angle triangle, like this is a right angle triangle, this one, because the one which is with an angle, that is base, this one is perpendicular, and this distance, that's the maximum distance, that is amplitude, which is sorry, by mistake, why I write this is hypotenuse by mistake, and this is perpendicular. So what happened? The perpendicular is the amplitude, the base is the length, and theta. So sine theta is perpendicular over hypotenuse. So we can say sine theta. What about perpendicular? Perpendicular is x. And what about hypotenuse? It is L. And so sine theta is x divided by L. What about theta? So theta, like, because sine theta is x divided by L, but this theta is very small. When theta is very small, this angle value is very small. So theta is approximately equal to sine theta. Theta or sine theta have the same value. So we can, so here A is equals to g sine theta, So, and sine theta is what? Sine theta is x divided by L. So in place of sine theta, I can write x divided by L, and this is G and here A. Or if I rearrange, I can say A is equals to x G divided by L into x. What is G? G is a gravity constant and L is a length that is also constant. So it means acceleration is directly proportional to displacement. So a motion in which the acceleration and displacement are directly proportional to each other, what we call that as simple harmonic motion. So again, you can see that when object is performing a simple harmonic motion, like a simple pendulum, its acceleration is coming out proportional to the displacement. So we are able to prove this relation. It means the mass which is attached to a string, it undergo a simple harmonic motion. Is it clear? So when a mass attached to a string, it is performing a simple harmonic motion, as well as when object attached with a spring is also performing a simple harmonic motion. So both cases it perform a simple harmonic motion. So if we compare the simple harmonic motion for the pendulum and for a mass which is attached with a spring. So vibratory motion in which the acceleration proportional to displacement or force proportional to displacement directed towards the mean position is known as simple harmonic motion. So we can have a mass attached to a spring, or we can have a simple pendulum. Then here the acceleration a is equals to minus k divided by m into x, and here a is equals to minus l divided by, sorry, minus, yeah, g divided by l into x. So this is g divided by l into x. And when we compare this simple harmonic motion with a circular motion in which a is equals to omega square x, so when mass attached with a spring performing a simple harmonic motion, and there's a simple pendulum vibrating to and fro. So when we compare with the circular motion, we can say omega square is equals to k divided by m. And here omega square, because like comparing the two equations, so x is there. So omega square is equals to g divided by L. And the time period, the formula to get the time period, t is equals to 2 pi under root L divided under root m divided by k for a mass attached to a spring. And here t is equals to 2 pi under root L divided by g. This is when object performing a simple harmonic motion, and that is attached with a string. So these are the important formulas which you have to keep when we solve the question. We'll use these formulas to work out the time period of either a simple pendulum or a mass attached to a spring. Then if we sketch a graph between the force and displacement, or we can also say acceleration and displacement. So if you are sketching a graph between the force and the displacement, or acceleration and displacement, we say if for a simple harmonic motion, the force is proportional to displacement, and directed toward the mean position, or acceleration is proportional to displacement also directed towards the mean position. So when we sketch a graph, it means when acceleration is positive, displacement will be negative, and when acceleration is negative, displacement will be positive. So the graph between the force and acceleration, or like if you have acceleration or force on y-axis and we have displacement on x-axis, so if one is positive, the other one will be negative, but they're directly proportional, so there should be a straight line. So what will be the graph here? The graph will be like this. As you can see here, force and acceleration are positive, but displacement is negative. Here, force and displacement are negative, but force and acceleration are negative, but displacement is positive. So the graph for an object which is performing a simple harmonic motion will always be the force acceleration, force displacement or acceleration displacement graph will always be like this with a constant gradient. And when we work out the gradient of this graph, so we have the formula A is equals to omega square x. So what we compare with y is equals to mx. So y axis we have A, x axis we have the displacement. So what will be our gradient? This is not the mass, this is a gradient. I can represent by g. So the gradient will be equal to omega square. So if sometime graph is given, you can use the graph and work out omega square. So how we can relate from where A is equals to omega square x, this equation, look, this is the equation for, we have the formula F is equals to m v square over r, and v is equals to r omega. So that is actually a formula for centripetal acceleration, that A is equals to v square over r. That is, and v is equals to r omega. So in place of v, we can write r omega. So we can say in place of v r omega, so we can say r omega square divided by r. When I simplify, I can say r square omega square divided by r square cancel. So A is equals to omega square r. So where A is the acceleration of the system and r is the displacement, so that will be omega square. So that is actually from the circular motion in which A is equals to omega square r. Now relating the displacement, the displacement, velocity and acceleration. So how we can relate the displacement, velocity, acceleration for an object which perform a simple harmonic motion. So if we are taking example of a simple pendulum, a mass which is attached with a string or a wire, and this mass is oscillating to and fro. So it depends on from which position we are observing we start the timer. Like example, to make this object vibrate, we have to take it to extreme position. But when we start the timer, it's up to us. Like example, student release the object from point A, but he did not start the timer from point A. When it reaches the point B, he started the timer, and then this object move in opposite, like move to other side, and then return back and continue to vibrate. So it depends on which position we start to consider the motion of an object. We can start from point A or we can start it from point B. If we start from point A, like if we consider A is the point where we start recording the motion. So here, when we start recording the motion from point A, it is having a maximum displacement. So this is the maximum displacement. And then when it is moving towards the mean position, the displacement decreases. Then it move in opposite direction, so displacement increase but in opposite direction. Like we want to sketch a graph for displacement time graph. This is a positive displacement and this one is a negative displacement. And here time. Positive displacement, negative displacement, and here time. So when we start observing the motion from point A, so at point A, its displacement is maximum. When we release, it moves towards the mean position, so displacement start to decrease. When it reaches the mean position, it move in opposite direction. So displacement from the mean position, distance from mean position increases, but in opposite, so negative. Then it returned back. So then it returned back and then it move in the same direction where we release. So it reaches a point. So what is this graph? Which is not starting from the origin, it is starting from a maximum value. So this is a cosine graph. So here the displacement is a function of cosine cos theta. But if we start considering the motion of an object, if we consider the motion of an object from point B, so object is at mean position, so object is here. Then it move away from the mean position. So it can be any direction. So it will go move towards the mean position, then it return back towards the mean position, then away from mean position, and then return back. And it continue to vibrate. So what is this graph? In this case, if we consider the motion of an object from the mean position, then it will be a function of sine theta. So it depends on from which reference we start to observe the motion. If we observe the motion from extreme position, the displacement will be the function of cosine theta. But if we observe the motion of an object from the mean position, then the displacement graph will be like for sine theta. So displacement graph can be cosine theta, can be sine theta. It depends on how we consider the motion of an object or which point we start the timer, or we consider that is a time where the experiment started. So if we consider the extreme position, like if we consider the motion from extreme position, so the displacement graph it will have a maximum displacement. The graph will start with a maximum value and then start to decrease and then another maximum. So what function will have the displacement graph will be a function of cosine. Now, what will be the velocity graph? So we know derivative, because if we differentiate or we take or differentiate with respect to time, or here we differentiate with respect to angle. So what is the derivative of cos theta? The derivative of the cos theta, that is minus sine theta. Good. So it means the velocity will be the function of minus sine theta. Means the velocity graph will be minus sine theta. So if we sketch a graph for velocity for an object which is performing a simple harmonic motion. So what is a graph for minus sine theta? Means it will start with a 0, but it will first then reach a negative value, then return back to 0, then maximum value, and then so this will be the velocity time graph for object which is performing a simple harmonic motion. And what about, so this is a velocity time graph. The first one was a displacement time graph. And if we want to sketch acceleration time graph for this object which is performing a simple harmonic motion, so the acceleration time, this is velocity time, and here displacement time. So again, if we differentiate this, so what is the derivative of velocity? That is acceleration. So this will give us acceleration. And what is the derivative of minus sine? So it will be because derivative minus will be there and derivative of sine is cosine, so it will be minus cos. So it means the acceleration graph will be minus cosine, means opposite of what it was for, like the mirror image of displacement. And it is obvious that we know for a simple harmonic motion, the acceleration and displacement are directly proportional. So if displacement time graph and velocity, the acceleration time graph should be mirror images of each other. So this is minus cosine, minus sine, and cosine or cos. Is it clear that if we consider the motion from extreme position, how the graphs we can sketch for displacement, velocity, and acceleration? And same way, if we consider the motion of an object from the mean position, so we can have a displacement time graph, velocity time graph, and acceleration. In exam, you will find a very common question regarding this. So the important thing, you should understand the concept of derivative. If you know velocity time or displacement time, you can find the velocity time. From velocity time, you can find the acceleration time. So here, example displacement time, then we want to sketch a velocity time, and at the last we want to sketch acceleration time. And we start to observe the motion of an object from mean position. So this will be the graph. So which graph is this? So it means displacement is given by sine. So what we have to do, if we want a velocity time, we'll take a derivative. So if we differentiate this, so this will be velocity, and the derivative of sine is cosine. So the velocity will be cosine graph. So means it will start with, it's positive cosine, so it will start with a maximum value, then decrease, and if we differentiate again, so this will be acceleration, and derivative of cos is minus sine. So means the velocity acceleration time will be negative sine. Negative sine means opposite of the sine graph. And always remember, so velocity, displacement time, and acceleration time graph can be used to recognize or identify whether it's a simple harmonic motion or no. So if they are mirror images like the two graphs, then it means it is a simple harmonic motion. Is it clear? The concept of the simple harmonic motion and the graphs which relate the motion of these objects. So the mass which is attached to a spring is also performing a simple harmonic. Then how to get the total formula, that we'll discuss, but I give you the introduction or to the topic, that how to identify. Like example here, displacement graph is what? It is starting with a positive value, so it means it is cosine, cos theta. So if displacement graph is cosine, then what will be the velocity? Because derivative of cos is minus sine, so this should be minus sine. And minus sine you can see clearly. And when we differentiate again, so it will be how much? What will be derivative of minus sine is minus cosine. So this will be minus cos. So displacement and acceleration graphs are actually the mirror images of each other. And the formula for displacement of a object performing a simple harmonic motion from the graph, x is equals to, x is a displacement where a is the amplitude, cos omega t. Why it is omega t? Because omega is, it is cos theta, but because the theta is equals, omega is equals to theta divided by t, so theta is equals to omega into t. That's why it is written omega t. So in place of theta, they write omega t. If you differentiate, the velocity will be minus omega, minus a omega sine omega t, and acceleration will be minus a omega square cos omega t. These are the derivative of the, so displacement, derivative of displacement will give us velocity, and differentiation of velocity will give us acceleration. Is it clear the concept that how we can relate the velocity, acceleration, and displacement of a simple harmonic motion? Then other formulas we'll discuss next session. Any question related to the class today?